Hello and greetings. This is question number 8 of October November 2024, paper 3 of A level maths, variant 2. So, in this parametric equation of a curve, we have 2 points x and y. X is equals to tan square of 2t and y is cos of 2t. And the range is between 0 and pi by 4. We need to show that dy over dx is equal to minus half cos cube of 2t. So first of all, we should know the trigonometric functions that can be derivative or differentiated. So first we have, that was differentiation because they are asking us to get dy of dx. So first we can take of into tan square of 2t. How do we take that? We get this square multiplied with this, you get 4 tan of 2t, and this derivative of tan square or tan is simply, we can say that it is, that's a trigonometric function identity, secant and 2t, and the angle, that is 2t, this will be just 2. So that would be of dy over dx, and the other is, we can say that this is dy over dt, and that was supposed to be derivative of t with x. I have written this wrong. That was dx by dt. So in the similar way, this would be cos has directly minus sine of 2t, and the angle 2t would just give us 2. So this would be dy over dt will only be minus 2 sine of 2t. So, but they are asking us to get the dy over du, so that can be using the chain rule, or we can just directly write it and then we can inverse the values or cross multiply it. So dy over dx, first of all we have dy is this minus sine of 2t, and the other value is over upon, so I can just simply write like this over the value that we have already known with 4 times 2, you can just simply write 4 tan of 2t secant of secant square of 2t. So that was initially 2 over here. Over here, later it became 4 over here. So now we can just simplify it. How to get rid of this tan and secant, we can just make it inverse. I would simply write 4, and instead of tan I can write sine over cos 2t plus, and secant square can be written as square of 2t. Now we can just multiply this, or we can do the denominator first. Minus sine of 2t times, so you'll have, you just do this directly, 4 times this and 4 times 1, so you'll have, oh my god, you have 4 sine 2t over, and this would give you cos cube of 2t. So this would jump and multiply with this one, and you would have minus 2 sine of 2t times cos cube of 2t over 4 sine 2t. This would cancel this, and this would cancel 2. So you'll have minus 1 over 2 of cos cube of 2t, and that was to be shown, and we have shown successfully. Yes, so in this particular we just needed to have the differentiation of tan, that was 2 was here, and then the function, trigonometric function tan has secant square, and in the similar way the cos has the derivative of sine, and we just multiplied this with that. After that we used chain rule and multiplied it and changed the tan to sine over cos and secant square to 1 over cos to get this thing simplified. This turned out to be multiplied with 1, cancelling this sine with this, 2 with this 4, that was shown to be proved, and we have proved it. Next is part number B, and it says that hence, okay, we have the same equation and we need to prove that the values when the t is pi by 8. So let's plug in the values. The values were same. हमारे पास था, we had x was tan square of t, but t is now, means it was 2t, so 2 stays here, and this is pi by 8, and the other value was y, that was cos of 2t, so cos 2 and t is pi by 8. So we simply say that it can be resolved as 2 would cancel this, so you'll have tan square, you'll be left with pi by 4, and the other side would be cos simply pi by 4. And if you solve this, so you'll get the value for this term, you'll get value for x is equal to 1, and the value for cos pi over 4, you'll get under root 2 over. Now these two values are the points or coordinates, but since the equation that we already have from part 1 that we have just resolved, so the gradient is now t is 1 over 8, so we can just simply plug in the value that was just shown, that was dy over dx, that is known as the gradient, and we know that it was minus half cos cube 2, and now we know that the t gradient is pi by 8, so we can simply solve this also. You'll get minus this cos cube, and this would turn out to be pi by 4, and turning out to be in a full cube, so this would be 1 over this. I can rewrite like this: cos pi by 4 cube, and we know that we have just found out the pi by 4 cos is 2 under root 2. So I'll just simply plug in the value. This and cube. If you take the cube of this, you'll get minus this. So this would turn out to be 2 this 8 and that would further simplify this with so you would just have dy over dx equals minus of under root 2 over 8. This can be the gradient, or we can say the normal of the line, but since it is negative, so we cannot have negative. We can change the signs or reciprocal of this. Later we can also do the rationalization. So you'll be getting 8 under root 2 over 2, and this would be just 4 under root 2 of the normal gradient dy over dx. So the points over here can be, one can be the first point, that was the point of the equation जो पहले निकला था, x was 1 and the y was under root 2 with the gradient of this. So the equation of line can be formed, but it is very mixed up. Let me just make some space over here. Okay, now we have the values x and y, and this is the normal, or we can say that the gradient, or m, is now 4 under root 2. The equation of line is known as y is equal to mx plus c, or if you don't have c, so we can say that c is 0. So y is equal to mx, but even if you don't have the y and x, so we know that we can take y minus the points. So y was this, and gradient is now 4 by 2, and in the similar way x minus, and the other value was this. This can be resolved, and by resolving this you'll get the value for equation of line. So either we can keep it like that also, but we can't, because that's equal to, we need to get rid of this. So let me do it here. You would have space in the exam, so this would turn out to be 4 times this. Let me just keep it as it is, and that would be just positive 2 over 2. So that would be the case, so we can keep it as it is. If you want to, like, we can simplify this. Let's do the simplification. Y equals to, so 4 under root 2x, then minus 4 under root 2, that would be left with under root 2 by 4. So if you just take the LCM of the other term, only this term, so you will have this 2 and multiply with this 2, so you'll have 8. So 8, and that would be plus 2. So 8 under root, and but this was negative, so you'll have 4 under root 2 minus 8 under root 2. This will be common plus this. That will also correct. But let's simplify. We are doing it now. So this would be the answer, minus 7 under root 2 over 2. And that was x. So that was giving us the same as equation of line. So it is a bit messy over here, but I believe it can be understood. Thank you.